Yes, hello, James. All right, optimization. Can anyone tell me what optimization is all about in MD2? All right, I'll tell you guys. So optimization is generally the idea of finding the best numerical target value using a range of input variables that are restricted by relationships and constraints. I'll write that down. So, all right. So if you have a problem and it's a numerical problem, if you have, let's say you want to minimize or maximize something or have like a specific number of something, and it's a complex problem because there's lots of inputs and lots of changing values. Um, optimization is about finding uh, it's about finding your target value. So the way that we do this in MD2 is we use Excel Solver. So Excel Solver is an add-on tool for Excel, which is used to solve these numerical problems, um, and really just lay out everything that you have, and then spit out exactly what you need. Do it again. All right, so there's a workflow with this, and we need a couple of definitions first. So first, we need the objective. Let's go objectives or objective function. So this is the aim of the question or problem, and it asks us what do we need to optimize, either its maximum, minimum, or target value. Next is going to be your variables. So these are the values that affect the objective. That's right. Next is your parameters. So these are the constants within your variables, or maybe your limits. Then you have your relationships. So that's the relationships between the variables and the objectives. Let's go values. Yeah, variables. Next are your constraints. So more limits for your variables. These shouldn't be limits. They should be set variables. Cool, 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 cool. And there's actually a workflow for you to go through if you ever get lost. And that's what it is. So first, you identify your need for optimization. This is your problem. So what kind of problem do we have? And like what is the goal of what you want to solve? Next, you choose your design variables or your target variables. These are the variables that affect your objective function. Next is going to be your constraints, then formulate objective function. Um, yep, you just keep going down, set up your variable bounds. So variable bounds are like these variable bounds. So like what is the maximum you can have or minimum that you can have? Then you write your optimization algorithm, which is your objective function, and then you solve it. So this is best learned through an example. So I'll pull one up now. Okay, here we go. This is the first problem. So the situation is there is a manufacturer that produces boxes and bins, and obviously it takes an amount of metal to make boxes and bins. And when this particular manufacturer produces these boxes and bins, there's going to be some scrap as well. And there's also a time constraint for each of these, and there is a selling value slash profit, right? So the question is, or the need for optimization would be, determine the combination of boxes of bins to maximize the return. So all right, need optimization. So he wants to maximize returns when producing. We'll go back to our workflow. Next, we'd have our design variables. So these are the variables that you have control over. So what you can alter, right? So for these, it'll be your boxes and your bin numbers. So number of boxes and number of, yeah. And I'll write a term for these. We'll make them x1 and x2, right? Next is your formatting your constraints. So the constraint that I can see here, I see three here. So the first one is resources. He only has 200 kilograms of metal. So metal upper limit, 200 kilos. Next is your scrap. So this guy wants to have to use more than 5 kilos. So he wants more than 5 kilograms of scrap. For whatever reason, maybe he's like taking it home to do home projects, whatever. So he wants this to be lower than 200 kilos. But he wants more than 5 kilograms to take home. Next is your time constraint. He only has 6 hours to make it all. And 360. Cool. Objective function. So your objective function is going to be your return for investment. So that would be the cost. So objective function would be, it would be the profit made on sales. So that's going to be, let's make it profit equals x1 times, so that's the number of boxes he makes, $3.50 plus x2 times 450. Cool. All right. So let's start writing these into something that Excel can uh, manipulate. So before this, we have to turn on Solver. So for this, you just got to go to Options in your Excel, then Add-ins, Excel Add-ins, and then Solver should be there. And once you do to it, Solver should come in for the Data tab. All right, so that is your setup. Cool. All right. Working space. All right. Then again, we need all of these. So first, objective. Oh, we can do objective last. So the needs are already there. Variables. So your variables are x1 and x2. Define these as boxes and bins. So I'm going to color these two squares because that's where I want the working squares to be. So this is going to be x1. It's going to be x2. All right, x1, x2. Next, you have your constraints. So the first one is the middle upper limit has to be smaller than 200. So to write this, I'm going to have a square here, make it equals, because for however many boxes you have, you're going to need 2.5 kilos of metal. So x1 times 2.5 plus x2 times 1.5. And we want that to be smaller than 200. Let's write that again here. x1 times 2.5 plus x2 times 1.5. So on the right, I'm doing the definitions just to remind me of what they are. Next is your scrap. So for each box that he makes, it's going to be 0.2, and each bin is going to be 0.3 of scrap. So the definition for this would be x1 times 0.2 plus x2 times 0.3. So there would be equals x1 times 0.5, 0.2 plus and it's going to be greater than 5. Next is your time. So for each one that he makes, it takes that much time. So x1 times 1 plus x2 times 4. equals x1 plus x2 times 4. Smaller than smaller than 360. Yep, sounds good. So what I'm doing here is I'm setting up, or explain after to the objective. So objective function just it rounds it all up. So equals x1 times 350 because that's how much money he'd make from that, plus f2 times 450. Cool. So what I'm writing here is a table that tells me how much profit I'm going to make if I alter how many boxes and bins I've got. I can do it the manual way, but then I'd have to check all of this manually and it would take ages to cycle through each number. Also, parameters. These are just the definitions for the variables itself. So x1, x2 is going to be an integer. That's going to be an integer as well. So what Excel does is it cycles these numbers, but it also cycles the decimal places. We don't want that because you can't make half a box or half a bin. So you want integers. You want them to be positive as well. You can't make a negative bin. And that should be what I meant to do. Whatever. All right. Okay. So this is how you would put it into Excel. Where is it? There you go. So click on solver. And these terms are going to look very similar to the terms that I'm using. So you just plug them in. So first you set your objective cell. So this tells solver what your goal is going to be. I'll click that to be that. And what do we want? Do we want a maximum value, minimum value? We want a maximum value because we want to maximize the profits. Let's maximize. And then by changing the variables, so these would be your two variables. So that's the number of boxes you can make and the number of bins that you can make. Click it. 1, 2. I held control while clicking those. Again. 1, 2. Then adding your constraint. So this value here, we want it to be under 200. So add cell reference this to be smaller or equal to 200. And then you add it. Next, you want your scrap amount, scrap, to be greater than 5. Yep. Next, you want your time to be under 360. Next, you got to add these parameters too. So x1 has to be an integer. That's one of the options here. x2 is going to be an integer. And then these two, you just make it greater than 0. That, 0, that, greater than 0. Oop. And press solve. Is that not a formula? Where am I right there? Go off. Cool. Find an integer solution with tolerance or constraints, blah, 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 blah. Sweet. F39. Oh, that should be 0.2, shouldn't it? Good spot. How did you see that? How's that? Is that the same? So it's smaller than 200, yep. Ah, right. Okay. So it doesn't seem too bad, right? It's a pretty simple question. There's only two variables and there's three relationship constraints between them. And that's what you get. Or if you wanted to, if you hated the company and you wanted to minimize your profits, that's what you do. You would make earning bins. Does anyone have any questions on what I just did there? So you just look at your problem. You look clearly at what your variables are, so what you have control over changing. And then when you look at those variables, what are the limitations? What are the barriers to what values I can choose? Then you just fit that into objective function. So you write out in a formula form of how these variables interact with each other to get your final value or what you want. Cool? I don't think well, the answers to this question should be on the supplementary materials, but we can do the tutorial question now. All right. It's a little bit harder now. So this is the next question. It says a log, a, a company owns 2 sawmills and 2 forests. Table 2.1 shows the capacity of each mill in logs per day and the distances between forests and mills. Each forest can yield up to 200 blocks per day for the blocks, should be logs, for the duration of the project, and the cost to transport the logs is 0.15 per kilometer per log. At least 300 logs are needed each day. Formulate the problem to minimize the cost of transportation of logs each day. Develop the constraints objective function only. Okay, so there is a company that has 2 sawmills and 2 forests. So the 2 sawmills and 2 forests have distances between them and they vary by this much. So with all of these constraints, what do you guys think the definition of the problem is? Like what do you think is the end goal here? What is he trying to solve? So the answer is in the second last line where it says formulate the problem to minimize the cost of transportation of logs each day. So to write it up again. All right, set up. Need for optimization. So he needs to minimize the cost of transportation of logs per day. So he has to figure out how much does it cost to get this log from here to there with these constraints. Okay, design variables. What do you guys think the design variables are? What does he have control over in a numerical sense? Any guesses? Okay. Yeah, that's one element of it. Logs transported. So it's a little bit different with this because he's got 2 mills and 2 forests. So from forest 1 to mill A, there's that much distance, and from forest 2 to mill A, there's another distance. So not only is it the logs transported, but you have to specify from which forest goes to which mill. So from which forest to which mill. So there's 2 dimensions to what you're doing. Where's the insert row button? Oh, whatever. There is an insert row button somewhere here, isn't it? Whatever. Okay, cool. So the first one I can identify is from logs from forest F1 to mill A, logs from F2 to mill A, logs from F1 to mill B, logs from F2 to mill B. Cool. So I want to write this again in shorter terms as, let's say, A1, A2, B1, B2. All right. A little bit harder now. Constraints. There are quite a ton of constraints in here, so let's try and guess some. Can you guys read the description of the problem and find a constraint? Things that affect or the limitations of what logs you can pick to which mill. Okay, that's a good one. Up to 400 or 200 a forest. So how do you think you can write that in equation form using A1, A2, B1, B2? Yeah. So do you think that could be A1 plus B1? Because that's the total logging from forest 1, right? Yep. And there's also another one. What's the other one, Ramson? Brilliant. I don't know why that's going that color. Okay, Lisa had another one. Yep. Nice. Easy. You guys are way too smart for this. Okay, give me some more. So we've done the blocks one, we've done that one. What else is there? Milk cap. Oh, jump the gun on that one. So mil cap B. What did I do right? B1 plus B2 smaller equal to 300. Yep. And why did you go with B first? Oh, hold on. No, we've already done that one. Bah. A1 plus A2 is smaller equal to 240. Does everybody agree? It's mil cap. You want to log less than this, or you want to bring less than 300 or less than 240 to each mil if you can't store it. At least mils. Yeah. Yep. 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 Cool. 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 Looks good. Okay. Before we do that, let's do the parameters first. What do you guys think the parameters will be? I'm sure there's a better way to do this. Not so much cost. That'll be your objective function. These are more to do with the definitions of these values. So more like, is it positive? Is it negative? Do you have integers? Can you log 0.5 logs from a forest? Not really. Me, A1, A2. I'm just gonna write it as this. Smart ass. So you want these to be integers, and also you can't have them as negative values because I don't know of any good techniques to return cut down logs to the environment. Please correct me if I'm wrong. Okay, objective function. How can you summarize all of this into one cost equation? So there's 2 bits of information that we haven't used yet. What are they? We haven't used anything to do with the distance yet, have we? Money and time? Yeah. Well, time not so much. We're just gonna assume that it takes 1 second to transport from forest 1 to mill A, or that it's negligible. Oh, this guy is an overachiever. Let's see what you got here. A1 20.5, B2 18.5. Ooh, close, really close, very, very close. Instead of 18.5, it's 18. Cool. And remember, when you're writing your equations, don't actually type in equals A1 because A1 is going to point you to that. So if you're writing something, do it like that times blah, blah, blah. What does that mean, Asher? All right, let's solve. All right, A1 blah, 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 that stays the same. Yeah. All right, this A1 plus B1 equals A1 plus B1. I'm just gonna write it here so I don't get confused. Remember, the colored bits are what is actually working. Everything else is just definitions. Yeah, you tried hard, man. You tried. A2 plus B2. Up to 200 forests per day. What? Up to 200 logs per forest. English. Next, at least all logs. So at sum of this. Meal cap B1 plus B2. Ah, no. Those are all integers, blah, blah, blah. That is fine. Now I can rewrite this. So 0.15, which is the dollar amount per kilometer. No, it's just to help me teach. Because people see all these terms and like, what the fuck's going on? A1 times 24. There's no real standard. A2 times 20.5 plus B1 times 17.2 plus 24, 20.5, 17.2. Cool. Solver. So objective function, bam. And you want to minimize your cost by changing the variables 1, 2, 3, 4. And then you add all these constraints. So I'll do all the smaller thans first. Logs per forest, smaller than 200. That one too, by 200. That is going to be smaller than, yeah, oops, click it. And then the sum of all logs has to be greater than 300. Next, all of these have to be integers. Damn it. So you got to do it individually. Oh no. Damn it. Yeah. What? What happened there? And then therefore got to be positive as well. Sweet. Da, 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 1, 2, 3, 4, 5. Yep. Cool. There you go. So what does this tell us about our company? So it says to minimize your cost, you wouldn't mine or you wouldn't log at all from mill forest 1 or 2 and bring it back to mill A, right? As you can see, these are much further than B. So obviously there's going to be more cost, right? But I don't think without writing this up with all your constraints, you wouldn't be able to figure it out. Except for maybe the mill caps. Yep. Cool. And let's say if we wanted to maximize the cost because we hate the company, that is how you would log every single day. And each day would cost 1200 bucks. That's it, mate. All right. That is optimization. Okay, which inputs? Do you mean these ones? Okay. So what I did was I first set the objective. So this tells Excel um, this tells Excel what your target value is. And then you set a goal as well. So do you want it to be maximum or do you want it to be minimum? Or do you want to make 1,000? Then what Excel does is it cycles through these variables 1, 2, 3, 4, so that like it chooses whatever values and it calculates um, which numbers would fit to get your target objective, as to max, minimum, or value. And then you set your constraints. So while changing these variables, what are your limitations? We said that the limitations are it's going to be up to 200 logs per forest. So this is your forest A. B1, B2. Sorry, forest 1 and then forest 2. So that would be tag value 1, 2, 3, 4. And the first one is how much do you want to log forest 1? And I want it to be less than 200. You can type 200 or you can just click the cell that has 200 in it because it's not going to change that. Next is going to be how much are you going to log forest 2? It's going to be smaller than 200 because So this is the definition of what's in the green cell. It's going to be A2 plus B2. So that square plus that square. Sorry, that square plus that square. And it's just a way of organizing all these constraints, values, and limitations. Does that clear it up a little bit? Cool. All right, next question is, where do you guys think that you can use optimization in the JDR report? Oh, yeah, so the parameters, where did it go? The parameters are so I wrote A1 has to be an integer, and you added it. So the integer is like our non-decimal number. The same with these values. So A1 has to be greater than 0. Okay. All right. So in the JDR report, there's lots of assumed values. There's lots of like distances, sizes, thicknesses, and all that that are assumed. Can anyone remember if you've started the assignment where you could, let's say, optimize or use Excel to help you figure out a better value than what is assumed? Shaft diameter? Yeah, that's a really good one. That's one that lots of people do in the assignment. But that's a tricky one because you've got to go to a table and figure out manually one of the K values, right? So I wouldn't go to the shaft diameter if I was you. Another one, that number of teeth for the gears for the fun ratio. Mm, I could see how that could work. Yeah. Could you chuck that into Excel though? Are there variables in the gear choices that you can guide to Excel? These are the questions that you have to ask. So the things that you're looking out for are, is there a clear numerical question? If you say yes, then go to the next step. Are there clear design variables? Like, are there clear numerical values that I can change manually that a computer can do for me faster? And next, are there clear constraints? Are there constraints that you can define numerically and relate to the variables that affect everything? The one other one that people usually go for is the distance between pulley centers. That's assumed to be 1500, but there's really no meaning to that. And that's one that you could do optimization for. Any other guesses of where you could put it in? There's quite a few, but whichever one you choose is up to you. Cool. Are there any other questions on optimization? How about the JDR report or the quizzes? How's everyone doing in this subject anyway? Has it been cruisy? Okay, so have you had a look at the report? Do you think that could be a critique that there is no optimization? Optimization um, in any report or any engineering design report is it's crucial, I'd say. So yes. Don't worry about the 3 points for that. The points The points would be where you would suggest you could use optimization for. So point it out and say why it's bad that he's not doing a critique, an optimization in the report. And then the other 2 points would be you suggesting where you could use optimization in the report, like specifying where you could use it. Okay, I think we're done here. Unless anyone has any other questions. Nope. Okay. That should be the JDR. Are you serious? I'm not leaving yet. Last I know, it was like the end of this month. So there was one date on UTS Online and one date. Let me just check this. Because I don't look after the tracking for this, but okay, so let me just share this. Do you guys see that? The due date is the 27th of September, midnight. What's the post date? Yeah, don't worry about the post date. But that's the due date there, 27th. It used to be right after Stuvac, and that's when people would panic and do it. But Stuvac for you guys is next week, isn't it? So you have Stuvac, and then a whole extra week, which is when you're starting CAD SolidWorks FEA. Yep. Yeah, so the quiz 3 is on the JDR report itself. So if you've done the report, you'd be able to smash that JDR report, the JDR quiz. Make sure you read that marking criteria. What else is there? Yeah, there you go. Don't worry about the subject outline. Alright, go away. Technically it is due this week. It's just the end of that week. Sweet. I think we're done. That's my last tutorial with you guys. I shall shed a couple tears. Rip in peace. Don't forget to do your student feedback as well. I get lots of funny replies that gives me a laugh there. Good luck with the rest of the subject, I guess. James, you're the one that's doing the Navy thing, eh? Yeah, good luck with that, sir. I don't think there's a tutorial class next week. Yeah, soon to be Captain A. Yeah, not that I know of. Lee. Nah, give it like 5 or 6 years, then you'll be sick of the Navy. You'll be like, why did I sign up for this? Yeah, no worries. They have been a lot shorter than they've been in the past, but we've just been told to cut this like to cut down the contact hours more and more and more. They're forcing our hand, but everyone understands the situation now because obviously the UTS isn't getting any more as much money, um, and shit happens. But I hope you guys have learned something valuable. I know this is like a unique subject compared to everything else, which is highly technical, but I hope you have enjoyed it, and thanks. All right. See you guys never.